Hello, everyone. We're going to start going through the 2015 test. So I'm trying to pick recent questions. I'm trying to pick FRQs that are non-calculator. Although on this, when you take the actual test, you will be allowed to use a calculator. They're just not going to put questions on that are ones that you have no choice but to use a calculator. So I'm going to mention as I go through these times where the calculator just is a time saver. Not that it's a necessity, but when you're actually taking the test on May 12th, you want to use it. So we're going to start with going through number 3. I think in 2015, 3, 4, 5, and 6 were all excellent as far as they were a variety of topics. They were things we've talked about, and they were things that you didn't have to have a calculator for. And here's question 3. So question 3 is a table-based question where you have someone who is jogging and the table is representing their velocity at different time intervals. So these are your times that she's jogging, and this is the velocity that she's traveled during that jogging. If you're looking at this going, how in the world is this negative? This might be something we didn't totally get into. Your velocity, the sign of the velocity is like a direction. So if it's positive, we would say we're going essentially to the right. And if it's negative, we're going to the left or we're backtracking. That comes into play later. So part A wants you to estimate the value of the derivative of v, so that would be acceleration, at 16. So when you're given a table and you're asked to do a derivative, it is truly just like an algebra, y minus y over x minus x. 16 falls between 12 and 20. So you want to make sure that you're using the values that are to the immediate left and right of it. So I'm going to take my v of 20 minus v of 12 over 20 minus 12, going to your calculator, getting those values, using a calculator to help you. You end up getting 40 over 8 or 5. I don't know how picky they would be on units. Usually if they want units, they actually state it. The units would be, it got cut off a little bit. It would be meters per minute, or you can write it as meters per minute squared. So for their scoring, for part A, they only gave 1 point. So I don't think they'd care much about units. I don't think they'd care much about work. As long as you got 5 using those values, you would get the first point. Part B wanted you to first explain what the integral from 0 to 40 of the absolute value of v is, and then find it using a Riemann sum. So first of all, it's the idea of we integrate to accumulate. And this may be a little beyond what we talked about in class, but I still thought it was a nice question because a lot of the things in the rest of the question are really helpful. So if you integrate your velocity, you're going to accumulate how far you traveled. So what the integral from 0 to 40 represents is the distance that she's traveled, the total distance traveled over that time period. And the reason it's in absolute values is because we still want to count the distance if we're going the opposite direction. Because if you're running to the right and then you turn around and run to the left, you want to count both of those running values. You don't want to just get the difference or the displacement. So I wrote that it is the total distance that she jogs from t equals 0 to t equals 40. And then to find it, doing a right Riemann. So your right Riemann means you're always using the right value on the table. And then you're finding your width of your interval. So from 0 to 12. And then taking that width times your right value. So 12 times 200, 8 times 240. Because there's an absolute value here, and this is really the only way it comes into play in your problem, when you do this third one where it's 4 wide, you're going to multiply by positive 220 because you want that distance traveled. That negative is just indicating direction. So 4 times 220 and then 16 times 150. So I just wrote those out. I didn't really show a lot of extra work. They may have showed a little bit more work. And then I did use a calculator. This problem was designed to be done without one, but on the actual AP test you guys are taking, use it for things like this to save you time. You end up getting 7,600. So their scoring system, they gave 1 point for explaining that it's the total distance she traveled, and I think they wrote it very similar to how I did it. And then they give 1 point for showing that you understand how to do a right Riemann, and then they get 1 point for the answer. So they showed a lot of steps for this. As long as you in some way illustrate that you understand what you're multiplying by, you get a point, and then your 7,600 would be your final point. Part C, now Bob is entering, and Bob is riding his bicycle. Instead of having a table, we actually have an equation for Bob. It is this B of t equation that's representing his velocity. And we want to figure out his acceleration. So the relationship is if you derive velocity, you get acceleration. So essentially we want b prime, or the derivative of b. So the first thing I wrote down is the derivative of b, which was just a quick power rule, 3t squared minus 12t. And then I'm going to put 5 into it. Here's another situation where on this question you weren't allowed to use a calculator. you want to use a calculator now anytime you can to save time. Put 5 in, you should get 15. I don't know how picky they'll be on units, but it should be meters per minute or meters per minute squared. And the scoring was 1 point for using b prime, so taking the derivative, and then 1 point for the answer of 15. So it doesn't sound like units were something that you had to have. They will tell you if you need them. And then finally, part D wants to know using the model B, so using the B equation, find his average velocity during the interval. There's a couple ways to do this. I like to think of it as average value. Average value is something we did in chapter 4. Average value is essentially area, which is integration, divided by width. We called it like the average height of a function. In this case, it's going to be the integration of velocity, so integrating velocity from 0 to 10, and then dividing by the width of the interval. So the way that I set it up, and I think you could do it a couple different ways, but I thought this was the easiest, is I wrote that down first. Like, how do you find the average value of something? You integrate it over the period of time, in this case 0 to 10, and then you divide by the width of the interval, which from 0 to 10 is 10. I integrated it by hand because this was one that was not a calculator question. So here's my integral by hand. And then I put my boundaries in. I did use a calculator for this to save time. The nice thing is when you put 0 in, you get 0. So I only cared about what you get when you plug 10 in. You get 3,500. Then you divide by your width of your interval, which was 10, giving you an average velocity of 350 meters per minute. And my answer seems pretty legitimate if you look at compare it to what Johanna was running. Hers were obviously a little bit lower, but she was running instead of riding a bicycle. So I like that my answer seems like it could be the case. So here is my work for that. Where I went too far. Sorry. Here's the rubric. So my integral, if you set up the integral, you get a point. If you actually did the integration, you get a point. That's this piece. And then if you got your answer of taking that and dividing by 10 and get 350, you get a third point. So 1 point for recognizing essentially what average value is, that integral, 1 point for actually doing the integration, and 1 point for the answer. So that was question 3. I will do each question in its own video, so your videos aren't super long and you're not bored to death. But I am going to continue and go over question 4 next and continue to load videos that way. There you go. Have a great day.